Hello students, sorry I'm out today. Today we are going to be talking about like multiples and like divisors. So first, pause the video and write down these two rules. Okay? Like multiples, if segments or angles are congruent, then their like multiples are congruent. And then like divisors, if segments or angles are congruent, then their divisions are congruent. So pause the video, write those down. And now we're going to do a proof. We'll go long way versus short way to show how wonderful this new rule is. So I know that P in P, so the big segment in P, is equal to the big segment in S. And then I know that O is the midpoint of NP. So that's a midpoint. And then that's a midpoint. And I want to prove that MO is equal to NR. And before, this was probably a pretty tedious process. Okay, so you got your givens. Since we have a midpoint, we know that NR is equal to RS. And we know that MO is equal to OP. And you don't have to write this long way down if you do not wish to. Then I would have to say something about NP and NS. So I would have to use a SAP. So NS equals NR plus RS. And MP equals MO plus OP. And then, now I would have to do a bunch of substituting. So I want to prove that MO equals NR. So I can first substitute, well, I know these two are the same. So I can say NR plus RS equals MO plus OP. And I want to focus on the NR and the MO. So I'm going to substitute. I know that I'm going to substitute NR in for RS, and I'm going to substitute MO in for OP. So I have NR plus NR equals MO plus MO. Then I would have 2NR equals 2MO. Then I would divide by 2. So what was this? This was substitution. This is also substitution. This was just simplifying, and this was division. So, with this new rule, this proof is now one step, which is super great. So, the new way, since we know these big segments are the same, we know the big segments are the same, and we know we have midpoints. So, those big segments are cut in half. Then their halves have to be congruent. Automatically. If the big segments are the same, then the halves would have to be congruent. Well, that's the rule right there. So you can just say MO equals NR because, and you would say since the segment is divided into two equal parts, you would say like divisors, or you could say like divisions. It's the same thing. Or if you really wanted to be specific, you could say like halves. Let's look at another one. Let's erase this. We'll try to do it the shortcut. Oh, that's the same one twice. So let's look at this one. It has angles. This again, sometimes life gets confusing when we name angles with 3 letters, but let's figure it out. TRY and ABE. And RW and RX trisect. That means 3 equal parts. So both of those angles are trisected. So I know this big angle is equal to that big angle, and these little guys are all equal because they're trisected. And I want to prove that TRW is equal to CBD. So Well, they have to be the same, right? Because I have these two big angles. It's a big angle and a big angle. And that big angle is divided into 3 equal parts. And that big angle is divided into 3 equal parts. So right away, I can just say this angle TRW equals angle CBD because of, again, like divisors or like divisions. Or you could say, if you really wanted to be specific, like triples. Let's look at this one. I've got MK is equal to FG. And then I know that KG bisects MJ and FH. MJ, so MJ is bisected. So these bigger segments are cut in half. And we know that these little parts are equal. But think about what you do. If you were to take this little part and double it, wouldn't you get the big part? Yes, you would. So you could do a proof similar to how the first one we just did. Or you can just say that MJ is equal to FH because of like multiples. And again, think about the process. If you took this segment and you doubled it, you would get the big one. If you took this segment and doubled it, you would get the big one. So sometimes it's confusing which rule you use. So go back to the beginning. Go back to your rules that you wrote down. You use like multiples. You use like multiples. You use this one if you know little segments or angles. And you're trying to prove the big ones. For this one, if you know the bigs are the same, and you want to prove littles. And that's all. So work on your assignment, and if you want, you can go ahead and get restarted on your review for your test, which is going to be on the long day this time.